Hi, we are going to talk about the mole, one of my favorite things. Now you will recall that the mole is the SI base unit for amount of substance. So really, what is this? Here's your definition. 1 mole is the amount of atoms in 12 grams of carbon-12. So if I have a pile of carbon-12, I put it on the scale, it weighs 12 grams. I know that there are, ready for this? 6.022 times 10 to the 23 atoms in that 1 mole. Now, a unit that we set right here that I wanted to point out. When we say 1 mole, it is the 6.022 times 10 to the 23 of any particle, okay, of any particle. Now, of course, in chemistry, we use chemistry particles like atoms, molecules, formula units, ions, compounds. We'll use this amount of substance in things related to chemistry. But it is actually the same principle as, I want to point this out, a dozen. Okay, sometimes students have a hard time wrapping their brain around, well, what is a mole? If it helps, for the first little bit until you get your teeth into this, you can think, oh, if I had a dozen, that means I have 12 of any particle. I can have a dozen kids, a dozen eggs, a dozen computers, a dozen pencils. If I say I have 2 dozen eggs, you know, oh, I just multiply that by 2. I have 24 eggs. If I have 3 dozen pencils, 3 times 12, I've got 36 pencils. That principle is the same thing for 1 mole. I could have a mole of Skittles. That would be death by Skittles, by the way. A mole of marshmallows. I could have a mole of batteries. Oh man, we would have a planet that would run New York for 1,000,000 years. You can have a mole of anything because we use this word right here, particle, just like the idea of 1 dozen. Now, this number we've given a name. It is called Avogadro's number. Avogadro wasn't the one that came up with this number. In fact, he didn't even come up with the principle of a fixed number. However, he did do experiments that laid the groundwork. And so scientists, in honor of the work that he had done, named 6.022 times 10 to the 23 particles equals 1 mole after Avogadro. So here's Avogadro's number. Now, I want to give you some examples of how large, really, this is hard to wrap our brain around, how big that number really is. If we look at planet Earth, we estimate that there's 1 mole of sand on planet Earth. So think about that for a second. If I say there's 1 mole of grains of sand on the Earth, how many grains of sand are there? Now, if you have to, think about, if I said, hey, I have 1 dozen grains of sand, how many grains of sand do I have? I have 12. Well, if I have 1 mole of grains of sand, how many grains of sand do I have? 6.022 times 10 to the 23. We estimate there's 1 mole of sand on planet Earth. This is kind of a fun one. If we had 1 mole of popcorn kernels, and again, if you need to, backtrack. Say, well, if I have a dozen popcorn kernels, I have 12 popcorn kernels. Well, if I have a mole of popcorn kernels, I have 6.022 times 10 to the 23. This right here, to give you a visual, a mole of popcorn kernels would cover all of the continental United States 9 miles high. Also, just by popcorn kernels, huge. Now, this is such a fun contrast. Oh, I just love chemistry. Water molecules. If I have 1 mole of water molecules, so if I have 6.022 times 10 to the 23 water molecules, there it is. There it is. It's about 18 mils, 18.02 mils. What does that tell us? Wow, if I'm comparing a mole of popcorn kernels that covers the United States 9 miles high, and yet I say, wow, that small amount right there, that is 1 mole of water. It tells us that molecules, elements, compounds, formula units, ions, they are crazy, crazy small. There's 1 mole of water, 6.022 times 10 to the 23 water molecules in that little beaker. Kind of neat. So there you have it, the mole.